Hello everyone, welcome to School of Electrical Engineering. So let's have a virtual tour. We can see a lot of major alumni who have been placed in different companies. Priti Kumari, she got IAS rank 2. Then we have our major recruiters from different companies like IT companies, core companies and different other companies also. In 2024 placement record, coming to the placement record, we have students placed from Maruti Suzuki at 13 lakhs package and other different companies like Whirlpool, TPS, Sidgil and various high radius. So this is 2023 graduated big students who have been offered different types of placement, and 2022 pass out batches who got different placement in various companies. So let's move on to different labs and we see the different departments also. So here we have different responsibility, different faculties who have taken different kinds of responsibility, and then different types of visitors who have visited from different foreign universities like University of Auckland, Netherlands, University of Savoy, France, IIT Kharagpur, Jadavpur University, Calcutta University. We have different years of program like bachelor degree program for 4 years, master degree program for 2 years, and then PhD program for 3 to 5 years, and PG diploma course on power and energy management for a period of 1 year. So we have certain best practices in our department like industry-institution collaboration, soft skills development initiatives, certification courses. We have employment assistant, student friendliness, and then we have curriculum design, drive for continuous and lifelong learning, tutor mentoring system. So we have different type of activities and best practices which you follow in the School of Electrical Engineering. Then we have different cells to monitor different kind of activities like tutor mentor cell, training and placement, student activity, examination. Separate cells are there for each unit to handle different types of work. Quality assurance cell, academic placement. So these are the different types of POs of the school, the program outcomes which we follow in our department. We have different MOUs signed with Suratkal, we have different MOUs signed with Bangalore, PRDC Bangalore, Gate Academy, Schneider Electric, then we have Enervision Mumbai. So there are different kind of MOUs signed with various companies. Then we have several research thrust area, basically meeting the Sustainable Development Goal SDG, 3 SDG Goal 7, that is for renewable energy and electric vehicle, machine and power electronics for 9, and 11 is for renewable energy, power quality, fact, smart grid and power generation. So in different areas our PhD students have taken places and they have completed also. In the areas of machine and power electronics, electric vehicle, power quality and facts, renewable energy, smart grid and power generation, electric vehicle, smart grid and power generation, machine and power electronics. So we have the various types of academics lab, we have various type of research lab and advanced research lab like basic electrical engineering lab, machine lab, networks lab, power electronics, electric drives, simulation lab, research lab. So these are the different student society. We are having different student branch chapter, IEEE Industrial Electronic Society, Power and Energy Society, Solar Energy Society, IET. Then we have IEEE Society for Electronic Society, Indian Society for Lighting Engineers. And these are the different projects which has been sanctioned by DST. So it is development of GN FET based high efficiency. So these are the different projects which has been sanctioned for a period of 3 years.
Okay, so let us have a virtual tour on the academic laboratories that we are having. So the main basic major lab that we are having is the electrical machines lab. So which is being taught in the undergraduate level, in the postgraduate level also students are doing the experiments over here. So let us start. So as you can see, in the laboratory we are having different machines. As we know, different type of AC machines, DC machines, transformers, experiments based on these machines are conducted over here. So as we know, machines has got widespread applications starting from your power generation, like your hydropower plant and thermal power plant, then move on to the industrial sector, then in the railway industry, then in the electric vehicle industry, then in the renewable energy sector. Everywhere electrical machine applications will be there. So we are conducting different experiments over here where the undergraduate students are conducting the experiments. So tables are arranged like this. So normally on one table, 2, 3 or 4 students will be doing the experiments at a time. So these are the experiments conducted on the AC series motor. Then we are having the DC compound motor experiment also. Then we are having experiments on transformer. So this is one of the vital machine which is used in the electrical engineering, basically for the power transmission and distribution purposes. So as we already know, for electrical power transmission and distribution, we use different ratings of transformer. So different testings and experiments are conducted in the transformer panel. Then here also we are having different motor generator sets. So experiments are conducted here also.
Okay, let's have a visit to some other labs also. So here we have reached to drives, electronics drives lab, and madam will be explaining the details about the scope of the drives lab.
So before moving to the electrical drives, this is basically the power electronics lab. As we know, India is progressing and we are now more focused on the control sector. That means in the industrial sector, how the machines will be controlled. So different kind of semiconductor devices and conductors are available. So basically the experiments based on the semiconductor devices like your thyristor, MOSFET, IGBT, all those things that will be conducted here. And taking these components into picture, the converter circuits which are designed, like your DC to DC converter, which is also called as a flyback converter, which is basically used for the SMPS applications. As you know, switch mode power supply applications. Experiment is conducted here. Then we are having different AC to AC converters, where power can be converted from AC again to AC, but the output will be a controlled AC, not a fixed AC, it will be a controlled AC. Similarly, we can have experiments on the converters, then three-phase converters, then we have the experiments on the uncontrolled converters, then we have the experiments on the controlled rectifier using different passive loads like resistive and inductive loads. Then we have experiments on cycloconverter where we can change the frequency also. This is interesting because we are going to change the frequency which normally we know is fixed, which is 50 Hz, but here we can control the frequency also. We can change the frequency beyond 50, below 50 also for different kind of industrial application. That is also required. Like for the aerospace applications, like for the industrial inverter applications, like for the induction motor control applications, you need to control the frequency also. So those kind of experiments can be conducted here. Then we have the inverter. So the very buzzword inverter, we know the use, very widely used, one of the use everybody is using in the home, which is the home inverters. So basically experiments on inverters are conducted over here. So basically this laboratory is conducting the experiments which is based on the semiconductor devices with the passive loads. The load will be either a resistive or a inductive load. So then we will move to the electrical drive, which is an application of the electrical machine and the power electronics laboratory. So that is interesting. Let us move. So this is our electrical drive laboratory. So already we have seen the electrical machine laboratory, then the power electronic laboratory. So this is the application of both of them. So after studying the electrical machine and the power electronics, we can move on to the electrical drive where a machine which is an active load which will be controlled by a power converter circuit. So that power converter can be a inverter, it can be a rectifier, it can be a DC to DC converter, but the load here will be a machine. And what kind of machine? Either it can be a DC motor, it can be an induction motor, whose speed can be controlled, whose starting can be controlled, whose direction can be controlled, which is used for several industrial applications. So if I can give you some simple one, suppose you are selling fan. So when you are controlling the speed of the fan, nowadays we are using the electronic regulator. So definitely electronic regulator with a fan load will come under the electrical drive application. Similarly, washing machine. When you are controlling the washing machine application, which is moving in the forward as well as in the reverse direction, again you are having the applying the brake also, that is also electrical drive application. When a train is moving, that is also electrical drive application, because you are controlling the speed and the direction, you are applying the brakes, so that is also electrical drive application. So different kind of power converter, like this is a dual converter where the load will be a DC motor load. So this is a DC to DC converter, this is a AC to DC converter basically. This is a single phase fully controlled converter, again with a motor load. So similarly we are having different converters over here where induction motor loads are there, DC servo motor load is there. So DC servo motor, interestingly, these are used for the robotic applications. Precise position control whenever you need, position control you need. Definitely for the robotic applications you need a servo motor. So servo motor parameters estimations can be done with this experiment or on this setup. So here also we are having different 3-phase converters with motor load. Then we are having the chopper, 4-quadrant chopper, which is basically controlling the motor in the regenerative braking, the forward motoring, the reverse motoring. Basically these applications will be in the electrical vehicle sector also. Electrical vehicle you need the regenerative braking, you need the electrical braking, you need the speed control. So those kind of experiments that will be controlled here, conducted. This is your inverter experiment. So basically industrial induction motors, which is used for the industrial application, that speed can be controlled using the V/F control method. So that can be done with an inverter, which is used in this experiment. So this is an induction motor load and this is an inverter panel completely.
One thing I would like to ask you, madam, when the students will be performing these experiments, so will they be competent enough to handle all the industrial things,
Definitely.
things they can handle?
So we are actually dealing at low power level, but basics are the same. When you are controlling a medicine, either you are controlling the speed or you are controlling the direction, you are applying the electrical brakes, and those things are actually required for the industrial sector.
One more question. These experiments they are performing in the laboratories, but when they go to real time, what challenges do you think they'll be facing when they'll be doing the real time experiments in terms of
safety. Major thing will be the safety and the precaution, and in industrial sector, definitely the setup will be different. Automation will be now coming. PLCs will now be
able to correlate the things from, because we have
definitely because all the basics will be cleared over here, so they can go to any industry with a prior knowledge, and after a little bit of training they can do the experiments.
So really the students are going to benefit from all these experiments and then work in the industrial field with all the experiments of power electronics, power lights, the very basic instruments they are using like washing machines, like ceiling fan, all these things are controlled with this machine labs or with the power electronics lab. So let's move on to our PLC lab and our electrical drives lab.
So this is one of the small application of your power electronics and drive lab, which you can say it is a electric charged cycle which is being running with a small motor. So our students have done this. So one of the prototype which they have
So
done.
we'll be moving on to the PLC and industrial automation lab, which is very much required in the industries. Nowadays industries are no more labor controlled, it is all controlled through industrial automation and PLC, and we have our PLC expert who will be explaining all the details of the PLC.
Hi, good morning all. So you see this is industrial automation PLC lab. As you can see, this lab is including all the advanced system. We are already having S7 1200 advanced PLC system, which is already industrialized advanced system, Siemens S7 1200, which is already mentioned here. This is completely fully automated system, which can be industry ready used. Why we are having the system? Basically, we are using it for developing the skill of the students, which is completely required in today's generation. Students need to understand this, the use of this PLC, because industry need this in today's generation. And when students are facing the industry during their placement processes, industry needs a kind of skill in every student. Now when the student goes through the skill process, and industry understand that student has this particular skill, then industry understand that skill and industry, there is a basic bridging, and which we are offering this industrial advanced skilling process, and this helps in bridging the gap in the industry and academia. so which is very much advantage for this university and the enhancement skill and enhancement process. And similarly, not only this we have all the advanced system, like we have Siemens, we have Allen Bradley, we have Schneider, we have other advanced systems like this. So this helps in not only training process, also project development, project management, all other enhancement processes.
Well said, sir. Sir, can you just explain me some of the questions, like can you tell me the basic industries where PLC is used, where students will be benefited?
Yes.
In which
I mean,
industries?
application wise, you can, I mean, all the assembly lines, all, I mean, factories, I mean, academic industries, automation industries, everywhere it is used. Every
energy
industry
sector, what
today,
about energy sector?
every industry, every energy industries, they're using their to enlarge their manufacturing unit using automation processes. So basically, production lines, heavy industries also they use industry automation.
We have SCADA in comparison to this. So how will PLC be benefited?
SCADA is basically an extension of this PLC. So if you know SCADA, this is very much helpful for the
So
students.
how our students will be benefited? Will they be able to operate directly all the industrial things, all the industrial automation processes learning from
helps
PLC?
industry. If you know industrial automation, you are basically understanding industry 4.0 and also 5.0, industry 5.0, and industry 4.0 and 5.0 are the future skill development
Industry
processes.
4 and Industry 5, right.
So this is very much important.
Thank you, sir. So PLC is just an industrial computer. It has wide application in cement industry, steel industry, automobile industry, and students will really be benefited and will be able to work on the industries after learning PLC and SCADA. So they'll have a confidence after learning from this laboratory. So we'll have now move on to the next power system lab. Where madam will be explaining a bit detail about the SMPS electric type system.
So recently we have a MOU and collaboration with the SMPS Electric, which is basically a collaboration work where the students will work in the area of electric vehicle. So as I have already told you, the sector of power electronics and your electrical drives, this is one of the advanced sector and most demanding sector now. So students will do research projects. Those who are interested to do it in the electrical vehicle sector, basically the first charging technology, the converter design, then the switch mode power supply design, they can do the experiments over here. They can go for the research line, they can go for higher study, they can publish journals and conference papers in this area also. So we have an industrial collaboration with this industry.
A student. Hello everybody, so welcome to Power System Lab. Today we have with us our own Director School of Electrical Engineering, Dr. Chinmay Kumar Panigrahi sir, and he is the giant in power system. Yes. So he will be explaining us with different types of experiments and how students will be benefited from this lab. Sir, please.
Yes. So very good morning, Dr. Arya and Dr. Vanishri. So it is a very high time for Power System Laboratory. Power System Laboratory, basically we have the different types of protection, digital system, numerical relay, digital relay, and also solar PV emulator, wind emulator. Lots of high-end equipments are here, and you can see this is our solar wind energy emulator. Here the students are more benefited with the cutting-edge technology, and they can also think of their startup in terms of solar energy, solar maybe maintenance, erection, all these things. So installation. So it is this laboratory is very much utilized by our M.Tech students, also PhD scholars and final B.Tech students, and lots of papers have been published in this laboratory. Two students are working day and night how to get values in terms of research value, ambience, all the things have been created in this laboratory. Thank you.
Very good afternoon, one and all. So myself, Chinmay Kumar Panigrahi, Professor and Director, School of Electrical Engineering, KIT Tube University. Yes, for last 15 years I am here, so I am serving in KIT in the capacity of a professor, and Also, I was heading Director Quality Assurance Cell, and I was also heading for last 10 years heading this school. KIT Electrical Engineering, the USP of KIT Electrical is industry field laboratory and also the research oriented and the industry driven laboratory. So, our students are excellent, our faculty members are also excellent. Whatever things for last since inception, KIT Electrical Engineering is always very friendly with the students, staffs and also faculty members. We are always we are just following the guidelines and instructions or advices, day to day advices from our honorable founder Professor Samanta sir. So, always we have in electrical department we have 15 number of academic laboratory, 5 number of research laboratory, and our students are always very much satisfied with the experiments in each laboratory, because they have all the technical assistants, faculty member in the laboratory, they are making the students a great feel of industry feeling. So, in each laboratory the cutting edge technology, the different types of prototype model under the direct leadership of our different faculty in charge of each laboratory, the students are performing well.
After conducting all the experiments, will be able to generate, will be able to transmit, distribute, and all with precautions and safety. So let's move to basic electrical engineering lab, which is the basic of electrical engineering department, where students will be learning the most basic things like KCL, KVL, what are the different types of electrical instruments, what is a wattmeter, ammeter, generators. So these are some of the panels which has been shown to the students for their knowledge. And let's move to BE lab.
Then what about
Next.
तो जितना बात कर रहे हो ना उतना मेरा काम बढ़ा रहे हो आप, मालूम है?
सब डाउन
सारे को वॉइस डाउन करना पड़ेगा, एक 7-8 घंटे का काम है.
Welcome to basic electrical engineering lab. So this is the lab which is mostly for the first year students of all the branches. So in KIT University, irrespective of any branches, student has to perform the first year basic lab experiments. So we have different experiments, like starting from DC machines, Mega to tungsten filament, star delta, and all the like your energy calculations. So we have different experiments. So here students will first learn safety precaution things, then students will be learning about what are the different type of instruments, how they will measure, because measuring instrument is most important. They will be learning about ammeters, voltmeters, what is a wattmeter, what is a multimeter. So different instruments they will be learning about. They will learn the basics of electrical engineering, because this is the fundamental things they have to know before going to any other laboratories or any other experiments or research. So let us have a glimpse of some of the experiments which they will be performing. Like we have study of Mega DC machine 3-phase induction motor. We have tungsten filament lamp experiments. And then we have Kirchhoff's law, that is basically two laws they will be checking, that voltage law, Kirchhoff's voltage law and Kirchhoff's current law. So these are some of the instruments they will be dealing with. These are the measuring instruments, as I told, DC voltmeters. And then we have the tungsten filament lamp, this is the rheostat. So practically after coming from their 12th standard, they will learn what are the instruments and how to measure these instruments. Then we have superposition theorem. Different theorems will be there to solve the electric circuits. Superposition theorem, Thevenin's theorem. So all these things theoretically they will not learn. Practically they will see how these theorems works and whether it is effective or not, so that when they go to industry they can make it perfect. So other experiments like fluorescent lamp, choke coil. Then we have measurement of 3-phase power, then transformers, RLC series circuit. So this is a basically set of basic electrical engineering lab. So let's learn from Sidel lab from madam. She'll be giving you some idea about home automation and industrial automation. So students can have real-time hands-on training from this Schneider lab.
So this is basically a research laboratory, which is Schneider Electric Laboratory. We have a collaboration with the Schneider. So welcome to this lab. So we are having different experiments on automation, which is conducted here. So different panels are there. Whether industrial automation, collaboration with PLC, IoT, those things will be conducted. Yes, domestic wiring, house wiring, how they have been conducted, how the connections is being done, those things we can learn here. We are having the building management system bench, where a complete idea on building management that will be given in this experiment. You can do it here. Then the home automation bench, how automation, because now we see that everything is being automated in the home also, total electrical system which is going to be automated. So those things can be experimented in the home automation bench. Then we have the energy management system bench, how to manage energy for the total home sector and for the industrial sector. So that is here. Then we are having the public address CCTV access control bench. This is our addressable fire safety bench, which is very useful. A lot of training is being conducted in this area. So this is from Schneider Electric. So these are the distribution panels. So work is already going on. So research scholars are sitting here for higher study, PhD scholars and M.Tech scholars. They do their research work here. So here already work is going.
Okay, let's see a magic in School of Electrical Engineering. So here we have home automation bench. Everybody would like to have smart homes. When we talk of smart homes, with a 1 inch of switch, we can able to control all the things. So here it is a KNX technology base, and this technology is developed by the Schneider Electric, and we are using this system to make students educated about the smart home automation system. And it can be connected with both the KNX technology as well as the wireless technology or Wi-Fi. We can connect and we can control here. So we can see here with just an inch of switch, entire thing is controlled, and with an inch of switch, all the lights, all the wirelets, all things have been controlled. So welcome to our industrial IoT lab. We have learned IoT means Internet of Things. It's the budge of the time. So let us learn what is IoT actually and how our students will be benefited with this IoT program. So welcome. Hello sir.
Hi,
So we'll be learning about what is basically IoT. We have known it is just Internet of Things, but what are the experiments performed here and how our students will be benefited after conducting the various experiments, and what basically they will learn.
Okay.
Will it be helpful for B.Tech, M.Tech and PhD students?
Basically, this one is an industrial IoT labs, and we build up this lab through our own students and the faculty members. Okay, and what exactly I just going to show you some of the developments that we make over here. If you check it out, here is the hub-based home automations. Okay, in the Schneider, you check it out. There is a KNX technology is over there. Okay, KNX technology, but here whatever we are developing, that is we are developing with the Wi-Fi technology and the open source. Okay, open source means anything you can get it from the open and you can utilize it. Okay, that's everything is open. The software is also open. You can get it from the GitHubs and you can apply this ones. Okay, so here's the entire ecosystems that everything is done with the help of the open hub systems. Okay, with the Raspberry Pis, you can check it out. Some of the Raspberry Pis technologies over here. Okay, so this is the mini computers we can consider. Now the next one, if you see, whenever we are talking about the IoT is basically start with the the sensor, then it's a sense the data, then it's transfer the data, that means the transfer protocol, and then it's the storage of the data, that means the cloud. So if you want to know IoT or industrial IoT, the basic things, that means the electrical engineering, you should know first. Then only you can jump into the protocols, and you can jump into the cloud computing or all other things over here. So right now you can check it out. Here is the intelligent energy monitoring devices already showing over here. So that is also we developed by our own. Okay, and here through these systems, the entire building, you can measure how much the consumption is going on. Okay, and even you can schedule. That means suppose this lamp is you want to work for 2 hours. That is also you can make it through this system. This board and another board is also here that our students are developed all this thing. That is smart GPU applications. Okay. So these 2 boards are combined together. Though they are not connected, but they combined together. Okay. Now you can check it out. This is a single hub. Okay. And here these are the Zigbee devices. Now the question is, what is Zigbee? Now you see, you know basically Bluetooth. Okay. The Zigbee is work just like a Bluetooth, but Bluetooth is basically one-to-one communication. That means one device connected with another device. But in the Zigbee can connect more than 250 devices at a time. So if you can check these devices, all these devices, this is called the occupancy sensor, this is called the door lock sensors, this is your humidity and temperature sensor. So all these are not connected with this one. Okay, so this is directly connected with the Zigbee. Okay, so this one is the Zigbee based home automation that you can make it out. Now we just jump it out to another platforms that is called the open source web server. So web server is basically, we are talking about web server, so this is a cup of tea for the computer science. This is not like that. Basically all these things the hardware is making through the electrical engineer itself. Then only the computer science will come. Okay. So this is the basic things, the students are doing all these things. And here is also the another Blink server, open server, that is the students are made in this lab only itself. Okay. Now come to the another the technology that the students is making. Here if you see, that is basically you just heard about the big companies is called the IBM. IBM is basically develops the Node-RED. Okay. So here the Node-RED server is already installed over there in the Raspberry Pi. Okay. So this Raspberry Pi is holding the Node-RED server, and these are the devices. They are the individual identity. So they are not connected with the server. Okay. These are the devices also. They are not connected with the server, but they are connected with the server. It's called the third-party server. That is called the Hive MQ. Okay. Now the question is, if we don't know exactly the hardware, then it's very difficult just to understand what is the IoT. And Internet of Things is right now is combines with the AI, with the ML, with the artificial intelligence. So it's a booming, and each and every industry now they are only jumping to the industry 4.0. So industry 4.0 means what? It's the Internet of Things. So you should learn Internet of Things without knowing electrical engineering is simply impossible. Okay, thank you.
Hello all, welcome to our simulation lab. We'll be learning from what students will be learning from this simulation lab. We have our own expert. Sir will be explaining the details about our. Hello sir. So can you please give us some ideas about what benefits students will be getting from the simulation lab?
Okay, this simulation lab basically start from third semester student onwards. We are there, know the hands-on of MATLAB. Apart from that, there is a higher softwares are there, which is related to majority power system and power electronics and control system like PowerWord, LabVIEW, Multisim, MyPower, digital power system. So by that what happened, they can do the different coding and simulation to analyze entire electrical system, and main thing is the LabVIEW. So by the LabVIEW they can do the different online control of a different system, which is a very important software which is available in our laboratory. Okay, thank you.
So welcome back. We have all visited different labs. We have learned different instruments, different safeties, and different types of modern automation system. But the man behind the entire thing, let us meet him, our own Dean, Dr. Vyomkesh Naik sir. So let's visit our Dean. Hello sir. So welcome to our thing. So we will be talking about with you few things about School of Electrical Engineering. So can you just give us a brief idea about School of Electrical Engineering?
Thank you, madam. First of all, I would tell you myself, the Dean School of Electrical Engineering. Myself, Dr. Vyomkesh Naik, Dean School of Electrical Engineering. I want to tell you that our main focus is the academic empowerment and the research activity. So that how to improve the academic empowerment, we are trying with our L&T EduTech for electrical vehicle specialization course and as well as the power system in smart building, how we are applying the smart building, that too we are dealing with it. Again, we are giving the number of intensive courses, that is summer intensive, winter intensive, that is the, as for example, MATLAB, LabVIEW and MATLAB, LabVIEW and PLC and industrial automation. All the things that is within 1 month, that is our experts are there. They can guarantee you that is if you are coming out from this 1 month intensive training, then you can absorb in the very good industry. So that actually what will happen, our training placement department, they are trying best so that how the student will place in the core company itself. So that mainly this year, that the Maruti Suzuki has come and has given that is the 14 lakh per package, per year package, and Whirlpool has come, and Tata Power, Whirlpool has given 11 lakh per year, and Tata Power, that is the 7 lakh package. The average salary package is all about that is 7 to 8 lakhs. Thank you.
So now let us move to our electrical library, which is the vital part of a university, or we can say in any school, because basically the students will come across the reference materials that they're following, the study books, the textbook, the reference materials, whatever they will follow. They can come take the books from the library. They can also sit in the library because this library is 24 hours open. So we have 2 sections of the library. This one is the circulation section where the books are being issued. So second section is students will keep their belongings over here. They cannot take anything inside, only except the laptops and the books. And this is the actual section, which is the reading room, as well as all the resources for the textbook and the reference books. They are being here. So let us discuss about the details of the library from our sir. So Samir sir, please let us discuss that, how the library is being utilized. What is the benefit for the
This
students?
is our reading room, which is opening round the clock. This is meant for Electrical School of Electrical Engineering users, and these are the new arrivals which are being selected through book display program. And these are the PhD thesis. All these records are in-house publications, and these are M.Tech thesis dissertations, and these are the bound.
Okay, let us interact with the students. As we know, already the summer vacation has been started. So basically all the graduate students and the master students, they have already gone for the vacation. But still we are having some international students and the research scholars are here. So we can talk to them. Hello Edwin. So what are you doing?
I'm studying.
You are studying? Okay, so you are in, what are you doing right now? You are in the M.Tech program?
Yeah, I'm doing masters in electrical engineering, specifically power system engineering.
Okay, you are in which semester now, right now?
This month, I've completed 2nd semester, this month 3rd semester coming.
Very good. So are you getting any benefit from the library?
Yeah, sure. It's not very resourceful for us, our study, improve us outside of the class, who come here and get more material to get ourselves built.
Very good. So are you interested for future research programs, or you are going for the job, or what? What is your plan actually?
We are still thinking on what next to do.
Okay, fine.
Yeah.
Best of luck for you. So you are here in the vacation also, you are staying in the university?
Yeah, sure.
Very good. Utilize your time properly in the library. Thank you so much. So now let us move to sir, who is also sitting here. Hello, Sikand sir. Hello, sir.
Hello.
Sir is senior professor from School of Electrical Engineering. So he is also sitting in the library. Let us talk to him. Sir, what are you doing here?
This is a 24/7 reading room. Whenever we need any assistance about literature review and survey through the books, then we come here and we study. Digital library is also embedded into this hard copies libraries, 24/7.
Okay.
So that becomes a boon for the faculty members and the researchers as well.
Okay. Sir, I think the research scholars are also getting the benefit for the online resources available.
Yes, the online resources are already there.
Like we are having the access to IEEE.
Yes, IEEE, Taylor Francis,
Yes.
Science Direct,
Okay.
the leading databases.
So students can download the journals.
Of course, we have subscribed to quite a good number of journals from the various databases. So there is no dearth of the availability of the online resources. Offline resources as well are also available. This functions 24/7, which is a boon in disguise for the faculty members, learners, undergraduates, postgraduates, and doctoral and postdoctoral researchers as well. Thank you.
Thank you so much, sir. Thank you for your valuable time. So now, Poonam, are you there? Okay. So she is a PhD scholar. So working on the final stage. So you are sitting here?
Yes, ma'am.
Every day you are coming?
Yes, ma'am.
And you are sitting here?
Yes, ma'am.
Okay. So what is your research area?
My research area is bead synchronization, basically phase lock loop.
Okay. So are you getting any benefit from the library?
Yes, ma'am. Definitely, I am accessing all the facilities which is being availed here. In this library, actually, there are multiple facilities. Like, if while doing our research, definitely there is the requirement of many books. We don't know at which time we may need any kind of help in our academic purpose. So if we need to study any book, then the reading room facilities there. Yes. We can choose any book according to our research and we can avail the facility. We can sit over here and we can study the book and then we can return. Again also, if you want to take the books into our home, then also we can get the books from the library and take it to the home, as well as the main facility over here is the internet access. The internet access is super fast over here, and also there is the facility that we can download any of the transactions and conference paper, because the institution has tagged up with the facilities like IEEE Explore and other databases. So whenever we need any for the downloading purpose as well as any book access, then we can do it and we can carry on our research in a very smooth and efficient way.
Very good. So just good luck for your future. Hope you complete your PhD work soon.
Yes, ma'am.
So thank you so much. So this is our reading facility which is available. Section wise it has been displayed. So student can take the book. They can read here also. They can also take the book to the hostel. They can keep it for some days and then also they can return. So anytime the library facility is available 24/7, and students normally prefer to do those who want to study for the core companies, if they are sitting for the GATE preparation, those who are doing that, for the higher study and for the research basically. Those who want to do that, they can sit here and they can peacefully do their work. So thank you so much.